Hello. Yes, my name is Oleg, and I'm a senior front-end developer at Perplexity. And today, we'll talk about the building user interfaces in the age of AI. Along the way, we'll try to decode the cryptic term generative UI and take a peek at how to make use of it in your production apps today. At Perplexity, we call ourselves an answer engine because we combine the index of a traditional search engine with the chatbot-style interface of generative AI. You ask a question, you get a concise answer in response, rather than just a list of links. Over the past year, we've spent a lot of time figuring out the best way to bridge the gap between LLMs and users, and today, I'm happy to share some of the findings. Before we go any further, let's zoom out and start with a question. This one. What defines great interface? Whoever attended today's keynote already knows the answer. A great interface is measured by the ability to help users to accomplish their tasks as quickly and as effortlessly as possible. Speed and reliability are the cornerstones of excellent software, and these traits are absolutely essential for any any product on the web. In fact, they should be foundational assumptions upon which all web applications are built. When we talk about speed, we are not just referring to technical metrics like time to first byte or network latency, but rather how fast users can access the information they submit, access the information they need, or submit their own requests. Consider how quickly a user can find an answer to their question, complete a purchase, or perform any other task central to your application. Every second saved in these processes translates directly into improved user satisfaction and often better business outcomes. Reliability. This one is self-explanatory. We want correct result 100% of the time. I'm sure by now you already heard the term generative UI. Not from me, but from someone else. And it seems like we don't have a dictionary definition for it. So I'll allow myself to provide my own. Born from merging together terms of generative AI and user interface, it is an umbrella term for any project that leverages large language models in order to enhance user interfaces. In its simplest form, it is a text query that is followed by a text response. But generative UI is actually a spectrum. As you can see, not long ago, pioneer products like ChatGPT and Perplexity offered text-to-text conversations. Right now, models are capable of generating structured data like JSON and render and markdown responses. It is inevitable that these technologies will advance, and we get to the point where we can generate full pages or even websites. Both sides of the spectrum have different requirements, trade-offs, and performance characteristics, but they are united by the crucial role of LLM. Sorry. So far, we defined the requirements for great software and now have an idea what generative UI is. The question is how to apply those principles and figure out whether it can be fast and reliable today. While it is tempting to offload the work of generating of the whole interface to LLM, this solution unlikely is performant enough. So, for example, if you ask Perplexity to generate a simple HTML web page, it will take around 5 to 7 seconds. And even if you cut this number in half, it will still be not acceptable by today's web performance standards. On top of that, you don't really have a way of reliably deploying that. And low Web Vital score and poor user experience prevents us from looking in this direction. Moreover, non-deterministic nature of LLMs also does not provide guarantees about safety and reliability. So you'll have to come up with novel testing approaches. On top of that, if you're using existing product with a design system, QA processes, and A/B testing framework, you can't use them right away. While generating runnable code on every user request is the great North Star goal and ambitious research project, it doesn't look like a production ready at this point. And yet, how can we take advantage of LLMs today? Let's go back to our spectrum and take a look at the left side. Amazing feature of modern LLMs is the structured output, a capability to generate responses in specific predefined formats instead of unconstrained free-form text. The output is usually defined by some sort of data description language, like JSON schema or similar. It works like this. You pass the schema along with the prompt, and you can safely expect the result to be in this format. What does it mean for the problem that we are trying to solve? Since we don't need the page markup to come from LLM, the number of tokens is greatly minified. That means dramatically improved speed and cost efficiency. We also can make use of all existing components, design systems, and A/B testing frameworks with minimal adjustments. One of the patterns that we've found incredibly useful at Perplexity is using schemas to define data requirements for our components. Taking a single presentational component and defining its props as schema combined with a structured output effectively allows you to plug it into LLM. Let me give you a simple example. Here you can say component for the timeline item. With a schema that is used to annotate the type of the props it accepts. I use the popular library called Zod in order to define timeline item schema, which would be an object with two required fields, title and the date. Zod helper infer helps me create the timeline item props type, which I later use to annotate the props of the timeline item. The rendering is trivial. We just return the fields. Assuming that we are working on educational app that renders arbitrary historic text as a timeline, this is how it would look like. Final schema to be passed to model contains an array of timeline items. The client implementation here is implementation detail here. Let's just assume that client get timeline returns a streaming response from the LLM, and the schema defined above is passed there implicitly along with the prompt. Sorry. Yeah, nothing unusual in the render method at all. We just render results as, oh, actually there is a typo. It should be result.timeline. Sorry about that. You got the idea. Timeline item is just a collection. So let's see how it works. Oops. Perfect. Yeah, this is something you may be used if you use Perplexity or similar apps. We successfully managed to compress the unstructured text of life of Alexander the Great into this streamable component. And in general, it looks fine. It looks like very much like we would expect it to be. However, as a front-end developer, I'm not happy about a couple of things here. First, the number of re-renders is definitely something that can be addressed. And on top of that, overall jittery of the UI, the flickering, we'd rather use the traditional loader to wait until the data is resolved. So, yeah, this is the shape of the data during the stream. We have 3 frames. On the first frame, we only see incomplete first item. The second frame contains complete first item and incomplete second item, and the third frame contains the result state. So how can we address the flickering issue of the interface? One of the patterns that we use at Perplexity is something called streamball schema. It is an implementation detail as well, since based on my experience, everyone comes up with their own solution, and there are a bunch of libraries right now on the NPM that provide helpers for doing that. But the important part here is that streamball schema accepts the final schema that you use and the incomplete result. And all the calculations and making sure, checking whether which item is loaded or not are performed there. So we need to modify our render method here and inject the metadata prop to the timeline item. So that should not autoplay, by the way. Anyway, yeah, this is the modification that we need to perform. Timeline item schema is defined as usual, inference as usual, and the props are now is a union of timeline item props and streaming metadata. So our wrapper component only injects the prop that flags whether certain component with a certain index has been fully loaded or not. So we need to have a minor change to our timeline to make use of isCompleted prop, and based on that, either render a loading state or the component itself. So what are the takeaways? If you care about speed and robustness and don't want to wait until the inference speed catches up, consider using LLMs as APIs for data, the way I showed you. Get rid of markup and just focus on getting the data, because it will buy you speed and reliability. The structured output with schemas will help you easily adopt existing components, A/B testing frameworks, and QA practices. And use schema streaming or similar approaches in order to address re-rendering issues, to work around the streaming nature of LLMs. Following these steps can leverage the power, help you leverage the power of AI in the products you are working on right now. That is it. Yeah, now we have time for your questions.
How do you detect when the schema has completed schema, like the partial JSON object versus when it's completed?
So yeah, this, as I mentioned, this is an implementation detail. You can, in order to, like, it depends on what you want. If you want to look at the whether the full object has been loaded, you can essentially write a helper function that checks this. Or if you want to see whether the fields individually have been fully loaded, the most important thing here is to remember that LLM is a sequence of tokens. So it will fill up your schema from top to bottom. So right now we had the collection of items with a simple signature. So we know for sure that the first item in the collection is fully loaded when we have the token that represents the second item. So it's sort of like look-back approach. All right, sir?
Sometimes it's a little bit slow to get a response for like really complicated JSONs. Like, yeah, the obvious thing is just to compress it into like symbols and stuff. Do you have any? That's a great improvement. So current LLM APIs, they tend to send either full JSON response or diff. So diffing, the process of diffing, you can move it into your application or do it on the server. Yeah, you don't need to like necessarily send full response. You can work with the diffs.
Whether it is a concern of a front end or a back end, that's actually up for debate.
Any tips, especially with Next.js, when you're streaming UI to make sure the cache stays up to date? Had some bugs like where you go back and forward and you miss the stuff that was streamed in recently because it wasn't in the client cache.
Mm-hmm. Yeah, that is a great question. So you have like a variety of options how to work with this. How you can stream JSON, you can stream text, you can stream React payload, you can send events via WebSockets or like server-side events. So it's tricky to come up like with the general solution. So I'm afraid here like we should like work with like depends on like the API that you provide. Yeah, sorry, it wasn't super helpful, but like the bottom line is it's just tricky to come up one-size-fits-all solution here.
Do you use JSON for everything that you're getting from the backend, or do you get any markdown from the backend, either regular markdown or HTML?
Yeah, we at Perplexity we have different APIs and we constantly experiment with them. So we don't have like the standard way of doing things. We also constantly trying to improve it in terms of like efficiency. But Markdown for us, we encode it as a string and work with this on the client side, which is something that we can iterate on for sure.
Thank you for the great talk. Here.
Sorry. Yeah.
So you gave us an example of the timeline.
Yeah.
But in Perplexity's UI, you also render a bunch of text and then have structured data.
Mm-hmm.
How do you handle different types of data that's streaming, and how do you handle if there's like a malformed data that's coming from the Gen AI API?
Mm-hmm. Great question. So this is why I would like to put emphasis on like schematization. So schemas not only help you agree on the format that you talk to your backend, but also Zod specifically provides you runtime validation. So you can do runtime validation for the data you receive. And based on that, if something is inconsistent, you can go ahead and render an error message or do a retry. Basically, however you see this works better for your specific app.
I'm very curious what's going on in the streamable schema component.
Yeah. Again, I was on the fence about like whether I should include it or not. I kind of feel like it would diverge carry away the attention from the points I'm trying to deliver. But all right, this is just a simple helper that tracks the state of the stream and arguments it, injects the required props to the components we are interested in. So no magic happens there. You can implement it by yourself. You can go as deep as you want. For example, you can instead of passing the props, you can pass a promise and use suspense down the component tree. You can use like proxy object that will render something entire. Proxies like in the place of the proxy object, which would render something entirely different. So it's very tricky to also come up with the, like one size fits all. The general idea is this is where you make a decision how you want to do it. It's also I would say it's tricky to come up with a library because of how flexible it is and how different the requirements are there. But based on today's talk, I assume there's some interest. So should I give an attempt on open sourcing that? You asked me, all right. Awesome. Maybe one last question?
I was a little confused on how does the streamable component solve the re-rendering issue?
So I had two GIFs. The first one, as you can see, the number of re-renders, essentially they happened on whenever each field was updated. So the number of renders was much higher than the discrete number of renders based on the number of components in the collection. So the first GIF showed like a few renders to just render the first item, and the same thing for the second one. While the second GIF showed that we have number of renders that is equal to the number of items in the collection. Cool. Okay, two last questions.
Oh, yeah. So I have a question that's kind of like totally out there. So like if I was streaming audio, like an audio response, is it more traditional to do something where you're like streaming chunks of like uncompressed audio data? Or would you create like an HLS playlist that has chunks of like compressed audio continually appended to it?
Honest answer, I have no idea how to make it properly. I won't even try. I won't embarrass myself. Yeah. One last question.
Hi. Oh, can LLMs right now reliably generate like the components themselves? Because I know like the component was pretty like hard coded in there. Has that something been explored so far?
Yeah, as I mentioned, the Gen UI is a spectrum. So like I try to explain why it probably would be a security concern. It's tricky to make it work with your existing A/B testing, your existing QA, your existing design team. So like you can't. It's definitely something like V0 doing a great job of bringing this vision to life, and hopefully a year from now, somebody on this stage will tell about how this is a solved problem. And whatever I was telling about is not relevant anymore. So I hope so. Awesome. Thank you so much. That was great.